Good morning, viewers and students. On 24 August 2022, we'll discuss non-destructive testing. Let us have a brief glance on this non-destructive testing. This material is taken from Daniel Studian, as it is not available in small books. It is an examination of an object which will not produce any kind of damage or destruction to the sample. Most of the cases, when we go for destructive testing, the destructive testing will spoil the object, spoil the specimen, will break out the specimen into two pieces, or some form of scratch or indentation will be found. But here, in non-destructive testing, when we see it, the examinations of it can be held clearly without touching the specimen. For using this, we will be using lightweight technique or X-ray diffraction technique, in which light will be emerging from the source and it will be falling on the object and it will be taking on the emitter, so that the emitter receives the signal and gets the respective recorded form. But the imagination we are going for it as X-rays, very old X-rays, in which a person used to stand. They'll be sending X-rays onto him, and the X-ray will be falling on a filament, and the filament will be given back to the person. Even photography also same thing previously. Using the same techniques, we'll be using this non-destructive testing. Here we'll be using the source. Source is especially a radiation that can be used to inspect the sample metal under test. A source can be a light wave, an X-ray, or a sound, etc. Next, we will be going for detector. A detector detects the signal which will be obtained from the emerging medium. A recorder is one which records the signal from the detector. Also, interpreter is one which checks the results through peaks, graphs, or diagrams. Using source, detector, recorder, and interpreter, we will be using this test and we will be checking this test in various things. Sometimes the specimen can be small, sometimes the specimen can be big, sometimes the specimen is regular, irregular, and based on the application, we can test the specimen. It can be as ASTM standards, it can't be on ASTM standard, but still we can go for this test. These tests are radiography, magnetic particle, fluorescent, ultrasonic, eddy current, and holography. Let us see radiography of metals. If we see the sketch clearly, in radiography, by external artificial means, we will be sending X-rays. These X-rays will be passed through the respective slit. They won't be passing continuously because of economical constraints or because of wastage of X-rays. These X-rays will be penetrated through the slit which is given, and after the slit they will be passing through the surface and they will be falling on the object. Even large thickness materials can be done here. Natural radiography materials such as radium, cobalt-60 can be used as this part. In most of these cases, if the material is too sensitive with X-ray, it can be used because of it metallic type of specimens can be used here. As soon as the X-ray goes and falls on the specimen, the atoms will be bombarded rapidly, and the voltage difference of cathode and anode will be passed, and this will be passed into the outer shield, or it will go to the detector. In detector, different forms of this, such as holes, cracks, internal flaws, inspection of castings, welding rods can be done in this technique. Next, magnetic particle inspection. In magnetic particle inspection, first the specimen will be magnetized. In order to magnetize it, we will be going for the specimen only as iron and steel. When we go for non-ferrous materials, this technique cannot be used. Here also inspection of cracks, laps can be done here. Once it is magnetized by either DC current or AC current, then it will be completely covered with fine powders or particles of magnetic. Some cases silicon particles will be taken, and a layer of silicon particles will be kept on the surface of this specimens. Cylindrical specimens, specimens of different cross sections can also be used here. So when we go for the specimen with powder, any cracks or flaws will be there, it will be covered. Then liquid magnetic particles will be flushed through liquid over the piece. When they were immersed or flushed, any flaws were there, any cracks were there, that cracks on the surface can be detected. In some cases, we are going for a construction of a house. So floor construction we have done. Out of floor construction, they will be going for watering technique. When they water it, regularly, frequently they will water, especially marble stones, decorative flooring. When they go for it, when they put water, they'll observe that any air holes, air bubbles, if they emerge, they will detect that there is a possibility of some blowhole there. Because of presence of it, bubbles will come. They immediately clear out the water, use a cloth, dry it, and put some more adhesive there. Here also we are doing the same thing. We magnetize the specimen, we powder the specimen with magnetic particles, we flush with water, magnetic particles, then we'll be checking any cracks. Most of surface cracks only can be held here. Next, fluorescent penetration inspection. This apart from cracks, shrinkages, porosity, small holes can be detected. This suits both magnetic and non-magnetic materials. In this, the workpiece will be either dipped, sprayed, or brushed with oil-like liquids. A viscosity liquid will be taken, and a viscosity liquid will be held on the volume of the specimen. After some time, the liquid is drawn or taken into the cracks. The liquid disseminates into the crack using capillarity action because it is a viscous fluid. The excess oil, sometimes we'll be going for oil. We can't measure that this surface must have this oil. If there is an excess oil which is held on the top surface, usually this oil will be wiped off either with a cloth or a mechanism. Now, a viscous liquid specimen is treated with a dry powder on the surfaces. Now, the penetrating oil from the defect, whether it is a crack or a shrinkage, especially at that region where there is a penetration of oil, when we put powder, then we can detect it as enlarging the size, or that area of penetration is clearly indicated or seen. When it is seen, we can detect that either it is a crack, shrinkage, or other part. Then we will be going for a specimen, taking the specimen to a microscope, and we will be checking the microscope through a 1000x magnification lens. We will be checking the accuracy of the crack. In another method, the test species is fixed and exposed to ultraviolet rays. Here also some cases we will be going for UV rays. And when we pass UV rays, and we will be getting back these rays, and we will be checking the variation of the light. If the light is uniform, it is good. But some cases, if the light is spotted with a dark spots, we can identify that the respective part have a flaw or defect in it. We also see the sketches of washing and black light viewing, from which we can go for inspection of cracks. Next, ultrasonic inspection. In ultrasonic inspection, forms a basic history. That is, in very old days, we used to check the flaws in a material by hammering it. As soon as when we hammer it, we receive the sound. If the sound is dump, we suggest that there is a porosity gap. You might have seen the rail track will become completely hammered with a hammer, and they'll be checking whether the rail is good or not, and they'll be informing if there is a crack held. This is based on the noise penetration or producing technique. Now, with the advancements in technology, we are not going for hammer, but we are passing UV rays. A frequency of 1 to 5 million Hz or cycles per second will be used for this process. Because of this million Hz frequency, this is a reliable and accurate type of process. And these sound waves will produce in all the metals or its alloys at a very fast speed in several thousand meters per second form. Ultrasonic waves, if we go out of the point, will be produced from piezoelectric materials. These piezoelectric materials will produce a huge effects of UV rays, and will be utilizing these UV rays on the metal or non-metal or alloys. The principle of piezoelectric effect is conversion of electrical energy into mechanical energy by different materials, producing variation of charges. The effect of this can also be held as piezoelectric effect. Now, because of a huge receiving of signals, we suggest the break or crack, that is the signals obtained from the metal. We check the flaws and we'll check the pulses. The pulses will be in continuous sine form or continuous continuity of regular rectangles or triangles. If there is a gap, we suggest that there is a flaw. Some cases we are observing a ripple on a river. When we see a ripple on a river, if it is uniform, we can suggest that the water is smooth and soft. But some cases when the ripple is going, at one point more ripples are generated by its own, then we suggest that a rigid rock is located at that region. We can identify that thing. We are not discussing more about the piezoelectric effect and the electronic part of the thing. We are not discussing electrical pulses more here. So we end off with mechanical orientation of ultrasonic inspection. Next we will be going for eddy current inspection. In eddy current inspection, it is also based on current detection wire wounding technique to generate magnetic law detection. It is used to check irregularities in the structure by variation in composition in electrically conducting materials. This is produced by varying magnetic field by a source of alternating current passing through a coil. In this the workpiece must always pass through a coil. The circumference of the workpiece must be wound with a coil such that a magnetic field will arise on the top surface of the specimen. Only respective specimens can be used here. We can't always use specimen as wood, specimen as a ceramic, as we require magnetic charges, electrical charges, eddy current, magnetic field to be produced. Then only we can detect flaws. So, materials such as iron alloys, some part of steel alloys can be used here. Now, we will check the magnetic field through a detector and we check the signals and pulses. If the pulse rate is uniform, we treat it as good specimen. If the pulse rate is not uniform, we will be checking that at that region there is a flaw or a defect. We can also check hardness using this eddy current inspection. Lastly, we will check holography. Holography is also kept under non-destructive testing. In holography, we will be using images. Different images of specimens will be taken, and these images will be kept in three-dimensional form. Using virtual techniques, this three-dimensional image will be kept in space. A three-dimensional orientation using CAD software and imaging photography will be taken, and this will be displayed in space. Now, because of displaying in space and rotation of the specimen, we can check easily through visualization the respective defects or flaws. So these techniques were under still study. The principle of it is a single wavelength light beam from the laser passes through a lens pinhole assembly to increase the area of coverage. After passing the pinhole, the diverged beam is allowed to reflect back and focused on the object. The reference beam as well as the beam get reflected and falls on the photographic plate or film finally. After developing the photographic plate, the final hologram is produced from which depth, hollowity or flaws can be found out. From the image patterns, we can detect stress-induced deformation, reveal cracks, flaws, unbounded areas, inclusions, etc. So these were the basic techniques, that is non-destructive techniques, to check the flaws. These were not held in textbooks, prescribed textbooks. So I have referred engineering material by Daniel Sudian. So from that we have discussed non-destructive testing. I feel that this part of material will be helpful to you. Have a good and bright day. Thank you.